brings a fresh and alternative OS that connects everything. This installment brings you Widget Applications. A widget is another type of native application, the other being the previous UI applications we've had. This will be your first steps into developing a widget app. One of the crucial differences between the UI application and widget application is their life cycle. As you have learned from the previous episode, UI applications have 5 life cycle callbacks: the app create, app control, app pause, app resume, and app terminate. On the other hand, widget applications have only 2 life cycle callbacks: the widget app create and the widget app terminate. Hence, the widget's life cycle is simpler. Unlike UI applications, widgets can have multiple instances. These instances are created by adding the same widget onto the home screen. Because of this, the widget instance should have its own life cycle. The life cycle of a widget instance is more similar with a UI application states. There are 6 life cycle callbacks in a widget instance. First is a widget instance create, which is called after the widget instance is created. Next is the widget instance update, which is called when an event for updating widget is received. Another one is the widget instance resize, that is called before the widget size is changed. We also have the widget instance pause and the widget instance resume, which are called when the widget is either visible or not. Last is the widget instance destroy, which is called right before the widget instance is destroyed. This diagram shows the process of creating multiple widget instances. When the first widget instance is launched, both the app create and the widget instance create callback functions are called. When the succeeding widget instances are launched, only the widget instance create callback function is called. If the widget application is terminated, the app terminate will be called, and all the widget instances are terminated. Now that you have learned the basics of widget application, we can now start coding your first app, an alarm widget. First, launch your Tizen Studio. Then create a new Tizen project by selecting File, New, Tizen Project. Select Template as the type of project. Then choose Wearable, Native Application. From the available list of templates, select Widget, then click Finish. After creating the project, let's add the assets or images that we will use for the widget application. To do this, expand the project in the Project Explorer and create an Images folder under the Resource folder. Then copy the provided images and paste them to the Images folder. Next, open the source code of the widget app by double-clicking the main.c file under the source folder. First and foremost, let me just delete this rectangle. In the source code, find the widget instance create callback function. The UI for each widget instance should be created in the widget instance create. As you can see, we already have a window, a conformant, and a label in this template. Let's modify the label object to create a title text for the alarm widget. First, resize the label by changing its width and height in EVAS object resize. Next, reposition the text by changing the X and Y position in EVAS object move. Then add the following code to set the text color of the title. From the default text color, which is white, we will change the color to blue with the RGB values 72, 156, 255, and the alpha value to 255. Finally, change the text value from Hello Widget to Alarm Widget. Now let's create the detail text object. To create the label object, type in the following code. We are adding the detail text inside the conformant, thus we will set the conformant as the object's parent. Next, resize and reposition the object. Then use the evals object show to make the object visible. Finally, set the text value of the object to add alarm. Note that we can put HTML tags to customize the text. Next is to create the alarm button. Add the following code to create a button. Then, same as with the detail text, resize, move, and show the alarm button. Now that we have the button, let's create a new function and name it as addAlarmCB. This will serve as the callback function for our button. In the addAlarmCB callback function, add the following code to print a log to our console. In order to call our callback function, let's add the following code to the button object. This line of code will add a smart callback to our button. That is, when the button is clicked, it will call the addAlarmCB callback function. And as the callback function only prints a log file, let's leave the data to pass as null. Finally, let's add a background image for the alarm button. Declare the following variables. Then get the resource path of the application. This is the path of the REST folder. Then add the following code to get the full path of the image. There we appended the resource path and the location of the image inside the app package. After this, we can now create the image object using the Elm image add. At this time, we will add the image inside the button, so we will set the button as the parent of the image. Next, set the image file of the image and set the image object as the content of the button. As the default background color of the button is blue, we have to make it transparent. To do this, add the following code in the alarm button. This transparent style is predefined to button objects. We're done now with the base UI of our widget application. Let's create and launch a wearable emulator. Then run the Alarm Widget app as Tizen Native Application. Your widget application should look like this. Now that we have developed our widget application, let's do one more thing. Let's connect the widget application to a UI application. The first thing to do is to have the UI application. Create another Tizen project by selecting File, New, Tizen Project. Select Sample as a type of project. For the step 1, select Native Application. For step 2, select the UI category, then the circle alarm sample. For the last step, set wearable as a development profile, then click Finish. Being connected means that data can be shared between them. To enable this, let's package the two applications. Right-click on the Alarm UI app and select Properties, Tizen SDK, Package, and Multi. Check the widget application and click OK. Try to run the Alarm UI app as Tizen Native Application. After packaging the two applications, running the Alarm UI app will also run the Alarm Widget app. As the two applications will now use the same data directory, a warning will appear as both applications have files of the same name. When we expand the shared REST folder of both applications, we will see the files with the same name. To resolve this, let's rename the preview image of Widget app from preview.png to widget.png. Then double-click the Tizen manifest.xml file of Widget app. Click the Tizen manifest.xml tab and change the preview image from preview.png to widget.png. Run again the Alarm UI app as Tizen Native Application. On the wearable emulator, go to Home Screen and swipe to left. Click Plus button and click the widget preview of the Alarm Widget app to launch it. Now that the Widget app and the UI app are now connected to each other, let's add a new feature when the Alarm button in the Alarm Widget app is clicked. The Alarm UI app should be launched. To do this, open the Tizen manifest.xml file and click the Privileges tab. Click Add and select App Manager Launch from the list. Press Ctrl S to save the changes. Next, open the source code of the Widget app. Find the EVAS Object Smart Callback Add function in the Widget instance create and pass context instead of null. Go to the Add Alarm CB callback function and add the following code to get the passed context and the instance ID of the Widget instance. Create the app control and set the usage of app control, which is the app control operation default. Note that the default operation of app control is to send launch request. Then set the app ID of the application that you wish to be launched by the app control. There, let's put the app ID of the Alarm UI application, which can be checked on the manifest file of the said app. Next is to the instance ID of the Widget instance to the UI application. This is done by adding the instance ID to the app control as extra data. Then add the following code to finally send the launch request. Make sure that the app control is freed after using it by adding the following code. Let's test the new feature of our Widget application. Run the Alarm UI app as Tizen Native Application. This warning says that the Alarm Widget app is already installed. To resolve this, we have to uninstall the said application. To do this, right-click on the wearable emulator and select Control Panel, App Manager, Uninstaller, then the Widget app. Then select the Widget app. Run again the Alarm UI app as Tizen Native Application. Go back to the home screen and launch the Alarm Widget app. Now click on the Alarm button. The UI application should be launched. To better understand the mechanism of our connected apps, let's try to understand the operations inside the UI application. First, open the source code of the UI app and find the app control callback function. This will receive the launch request that is sent by the Widget app. We can see that this callback function gets the data from the app control signal sent by the widget, which is the Widget instance. When the UI application is launched, a clock will be displayed, enabling the user to add a new alarm time. When the alarm is set, the alarm set time for widget will be called. Let's find that callback function. As you can see, the alarm set time for widget callback function saves the data as a bundle with string type key value and then calls the widget service trigger update method to trigger the update event for the given widget instance. As you have learned previously, the widget instance has a lifecycle callback that receives update events, the widget instance update. That is also the reason why we sent the instance ID of the widget instance to the UI application, so the UI application will know which instance should receive the update event. The final step is to display the alarm time on the Alarm Widget app. To do this, let's go back to the source code of the Widget app. Add the following objects into the global struct variable widget instance data so that we can access the objects in other functions. Add this, then let's start changing the scope of the objects from local variable to global variable. Now, go to the widget instance update callback function and add the following code to check if the requested operation sent by the Alarm UI app is set alarm. If the condition is true, let's change the UI of the widget to display the alarm time. First thing to do is to change the text. Add the following code to resize and reposition the label object. From the previous text color, which is blue, we will change the color to white with the RGB values 255, 255, 255, and the alpha value of 255. Then change the text value from alarm widget to the value of the alarm time. Next, add the following code to remove the detailed text. Next, modify the button by adding the following code to resize and reposition the button. Lastly, add the following code to change the background image of the alarm button. Now let's check the connection between the widget and UI applications. First, run the Alarm UI app as Tizen Native application. Go back to the home screen and launch the Alarm Widget app. Now click on the Alarm button to launch the Alarm UI app. Set the alarm time by selecting either the hour or minute, rotating the bezel to adjust them, and clicking Set to save the changes. After setting the alarm, click the Cancel key to go back to the widget. The widget should now display the alarm time. And that is how to develop widget applications. For more information on the Tizen OS, go to the links found on the description below.